Okay, so for problem 1 from the quiz 2 week 7, we have to determine the tension in the wire where transfer pulses travel with a speed of 200 meters over second with throughout a taut copper whose diameter is 1.5 millimeters. Okay, so we have now to put the formula that relates velocity and tension, which is velocity is equal to the square root of tension over mu. So we just clear here for tension, and would be tension equal to velocity squared times mu. Okay, so we have this. We know that mu is equal to the density times the area. So mu is equal to density times the area. And we just substitute here. So we have that density, area, and velocity squared. We already know, because the problem is giving that the density is 8.92. So we know that tension is 8.92 times the area, and the area of a circle is P, well, we already know P radius. We have the diameter, so we know that it is in millimeters, so in order to have everything in meters, we just substitute that, and we have that 1.5 times 10 to the 3 meters over 2, because we need the radius, not the diameter, times the velocity squared. We already have the velocity, so we just substitute here. And we have that the tension is equal to 63.05 newtons. Okay, so for problem 2 of the same quiz, we have to determine the tension in a wave speed of 30 and the same one where the speed is 20 and the tension is 6. Okay, so we first, we already know the formula for velocity, which is square root times mu, and well, we would say that it would be the same. We can make this to equal, and we have that mu is equal to the tension 1 times speed 2, that would be equal to force 2 times speed 2. And okay, so we just clear for tension 2, and we would get that tension 2 is equal to velocity 1 over velocity 2 over velocity 1 times 1, and we have all the values. So force 2 is equal to velocity 2, which is 30 over 20 times 6, and force 2 would be equal to 13.5 newtons. Okay, so for the quiz 3 of the week 7, we have to determine the average rate at which the energy is transmitted along the string if the linear mass density is 75 grams per meter. Okay, so we have our function where we know that the amplitude is equal to 0.350 meters, omega 10 pi, and k is equal to minus 3. K is equal to 3 pi. Okay, so we have first that, okay, the formula we will use is this. Okay, so we already have all the values, but we are missing the speed. So we know that the speed is equal to the wavelength times the frequency, and this is equal to omega over k, and we already know these two values. So we have that is 10 pi, 3 pi, and this will be equal to 3.33 meters over second. Okay, so now we already have all the data, and we can determine the average rate. So we just substitute the values, and we have that, okay, this is not density, it's power. Okay, the 1/2 of mu, which in this case would be to the minus 3 meters over second. Oh, I'm sorry, it's not meters over second, it's kilograms over meter. And the omega squared, which I already know, which is 10 pi squared, amplitude, that this would be this one. And the velocity, which we get here, which is 3.33 meters over second. And as a result, we have that the power is equal to watts. Okay, so we already have the average rate, and we have to find the equation which relates the average rate and the energy contained. Okay, so we have that the energy contained is equal to the energy over time. And we just clear here for E, for energy, and we would get power times time. We already have this, and we have to determine this. So we know that from omega is equal to 2 pi over time. So we just clear here for time, because we already know omega, and it would be 2 pi times omega, which is 10 pi. And we have that the time is equal to 1 over 5 seconds, because these 2 get cancelled. And we just substitute here. Energy is equal to 15.1 watts times 1/5 second. And this is equal to 3.02, and the energy is determined in joules. So this is our result.